Hola, pre-calc peeps. Today we are going to pick back up with more polar graphing. So you can go ahead and give your notes a title like so. And if you remember last class, we ended with the example of 2 plus rewind. That is definitely supposed to say r equals 2 plus 2 cosine theta. Okay, and who remembers what shape that made? If you said a cardioid, you are 100% correct. Now, if you said a heart, that's the exact same thing, but just not as fancy. But it made a cardioid. And this is a specific type of graph, and it's referred to as a limacon. Okay, and we'll do more with those. And let's go ahead and jump to our next example, another graph, and we will do r equals 4 plus 3 cosine theta. So what I want you to do is to make a theta r table all the way from 0 to 360. If you need more room, come on over to the other side and fill it out, because I know I'm going to. I write big. So pause the video, take a minute, fill out your theta r table, and come on back. Okay, so there's my theta r table. Check to see if yours looks just like mine. You should notice that from 0 all the way to 180, we go from 7 down to 1, and then as we go 180 back to 360, it repeats. So let's go ahead and plot this. 7, 0, and then I'll jump to 6.145, remembering that each of these lines around our polar graph represents 15 degrees. So 490, 90, make that dot a little bigger, maybe not. 2.5, 120, and we'll do 1.9, 135, roundabout, right, looks a little past 1.9, it's okay though. 180 is going to bring us right there. And we keep going the other way around. So 1.9 back to 225 is going to be right about there. 270 there. Sorry, it definitely dotted where it wasn't supposed to while I was counting. And then we have 5.5, 300. And 6.1, 315. And that's enough for me to see exactly how to plot this guy. And so we'll start here. I'm going to go out and back in. Now, you might be thinking, Ms. Gutierrez, it looks a lot like the cardioid we did last class. And you're close, it does. The only difference is it does not return back to the pole. So, you might have remembered earlier in this video, I used the word limacon. Well, this is a limacon with a dimple. So, that's what we're going to call this one. Alright, we have one more limacon that we are going to take a peek at, and that will be r equals 2 plus 3 sine theta. So, one more time. Pause the video, make that theta r table as much as you need to, all the way around from 0 to 360. If you need more room, go over to another side, and come back, compare yours with mine, and then we'll graph. Okay, so check your theta r table and see if it looks like mine. Now, you might have been working through this going, great, from 0 to 90, totally new numbers, and then go, ooh, from 90 to 180, it repeats. Why do I need to keep going? Well, from 180 to 270, it's completely different numbers. And from 270 back to 360, then that group repeats. So let's see what this looks like on our graph. Let's thicken my pen so that way I could actually make a dot. And here we go. 2, 0. There. And then I'm going to do 3.5, 30 degrees. 4.1, 45. That's a little bit more than 4.1, so we'll just be careful when we say 4.6, 60, 590, 4.6, 120, 4.1, 135, 3.5, 150, 2, 180. So that looks like it almost makes our entire figure. So what's going to happen as we keep going through here? Well, we have 0.5, 210 degrees. So let's see if I could even get this to plot on there. That's pretty close. Okay, negative 0.1. So I'm going to go to the left. Yikes, negative 0.1 and go around 225 degrees. That's going to take me right in there. Then I'm going to go negative 0.6, 240, about there. Negative 1 to 70 is up top there. Negative 0.6, 300. Negative 0.1, 315, getting really tiny in here. And 0.5, 330. So that's positive 0.5, 330 is going to take us around here. And then we have 2, 360, gets us right back to where we started. So, what does this look like? Well, this graph is another limacon, but it's going to loop up inside right here. And this is going to include what is called an inner loop. Okay, so we've talked about 3 different types of limacons. Let's recap that and get rid of the scrap paper because we don't need it right now. So again, these are called limacons. Now, you might be looking at this and go, Ms. Gutierrez, that certainly looks like it's written as limacon. Well, technically it's French, so it's pronounced limacon. I think it actually might be limacon, but I'm going to call it limacon. If you want to call it limacon, that's on you. Go for it. It doesn't bother me in the slightest. These have the general form of r equals a plus b cosine theta, or r equals a plus b sine theta. Now, if a and b are different numbers, that's what creates the different shapes. The first one we looked at was a equals b. That created that lovely heart that we call the cardioid. And then we did, what was the next one? We did the dimple. Okay, so that's when a is greater than b, that you have the dimple. And then we did a is less than b, and that's where we had the inner loop. So these are 3 types of graphs that you would have to be able to do again. And again, those are called limacons. Sorry for my pause. And let's move on to talk about another type of graph with polar graphing. Okay, so the next polar graph that we're going to look at takes the shape, well, has the form of r equals 2 sine 2 theta. So again, go ahead and make our theta r table. Now, for this one, I don't want you to go all the way to 360. Okay, what I want you to do instead is to do your theta r table from 0 to 90, and then, I lied, don't do that. Let's just talk this through one together. I was going to try to save time, but I can't. Because of that 2 theta, it makes things a little different. So, here we go together. When you plug in 0, 2 times 0 is 0, the sine of 0 is 0 times 2 is 0. Okay, great, fantastic. 0 is easy. Then you have to look at the next thing you're going to pick. And you're going to say, like, Ms. Gutierrez, let's pick 30, because we always pick 30. Well, actually, when you plug in 30 for theta, you get 2 times 30. That's actually going to give you 60. So, great, but that's not the next thing. If we want to look at the sine of 30, what are we going to plug in for theta? 15, exactly, we're going to plug in 15, if I can actually get it to write on here. So, we plug in 15 degrees. 2 times 15 is 30. Sine of 30 degrees is 1/2. 1/2 times 2 gives us 1. Continuing on, the next one we normally would plug in is 45. If I'm plugging in 45, that would give me 90, because 45 times 2 is 90. So instead of plugging in 45, I'm going to plug in 22.5, and that, when I plug it in, will give me 45, and that'll give me approximately 1.4. Okay, continuing on and following this, you're going to get 30, 1.7. 45 is going to give you 2. 60 is going to repeat back to 1.7. And then we're going to have to go 67.5, because that would give us 135. And that's going to give us 1.4 again. 75 would give us, why did I write 750? Whoopsie daisy, erase that. That's going to give us 1, and then 90 is going to give us 180, 0. Okay, so we're going to go with this, but when we go to graph this, 0, 0, that's our pole. Okay, 1, 15 degrees. How nice for that to already be marked on there. 1.7, 30 degrees. Okay, 2, 45. 1.7, 60. 1, 75 degrees. So we have this graph right here. I hate to break it to you, that's not the entire graph. So let's keep going with this. Let's just figure out the coordinate points that are going to help us get the value of 2 or some version of that. So continuing on with this theta r table right here, what can I plug in that's going to give me 2? Well, if I plug in 135 times 2, that's going to give me 270. That'll give me negative 2. Okay? The other value I want to look at is what's going to give me 0. That's going to be all of the 180s or the 360s. So, let's keep going. Graph that now. Negative 2. 135 is going to end right here. And then 0, 180s back to the pole. And that's going to give us that part right there. Keeping going, if I were to plug in 225, that would give me 2, and 270 would give me 0. Now, when you multiply by 2, yes, that's greater than 360, but it's going to be the equivalent of 90, 180, 270, 360. So let's graph that part. 225 degrees puts us out here, and back at the pole gives us that one, and uno más, when we plug in 315 and 360, that's going to give us negative 2 and 0, negative 2, 315 up here, and there we go. And this is what we refer to as a 4-leaf rose. Why do we call it a leaf or a rose and not a petal? I don't know. I really don't. But you can call it a petal if you want to. But now what I want to do is turn to your calculators. So pause this, take a moment, get to your calculator, and then we're going to start to look at what happens graphing in polar form on our calculator. Okay, so now on our calculator, the key things that we need to highlight are you need to go to your mode. In mode, we are no longer dealing with functions, we are dealing with polar. So you want to turn mode to polar, and then you also want to be in radian. Okay, so we want to be in radians and in polar form. So now what I want you to go is to go to y equals. And when you press the y equals button, you're probably going to go, whoa, because now we're not in function mode, we're in polar. So y equals comes up as r equals. Go back and type in the problem we just did. So 2 sine 2x. Oh, when you hit the x button, it comes up as theta. All right, and then you hit graph, and you have these pretty little 4-leaf rows that we just did. And notice the diameter of each leaf is 2. Okay, so now what I want you to do is please graph r equals 2 cosine 2 theta. And tell me, how is it different? Any guesses before you go on and graph it? So take a guess and then see if you're right. graph it, and see what happens. So when you switch it up and you make that sign cosine, it rotates slightly along the x-axis. It shifts. Just like when we are graphing circles and limacons, if it's on the x-axis, so to speak, it was with cosine, the y-axis with sine, same sort of thing. Now go and take a look at r equals 3 sine 4 theta. Here's what I want you to think about with this one. How many leaves is this one going to give you? Because the 2 cosine 2 theta was a 4-leaf rose. So what's 3 sine 4 theta going to give you? Well, that's going to give you how many leaves? Sorry, pausing and graphing it on mine also. And it's a crazy 8-leaf rose. It doubles. Okay, so now one more I want you to graph, and let's graph 3 sine 3 theta, and take a guess how many leaves this one's going to have. And you guys are all probably saying, duh, Ms. Gutierrez, it's going to have 6. Everyone has doubled. Let's see if you're right. So go ahead and graph it. And then you go, wait a minute. It only has 3. So, here we go. Let's talk about r equals a cosine theta and r equals a sine theta. And these give us our roses. So I'll say is a rose. But how are they different? Well, if, rewind, I left something out here. I jumped the gun. I heard my phone go off and I was slightly embarrassed, and I forgot to include n theta. N theta. And that n is crazy important because if n is even, then we double the number of leaves. And if n is odd, then that equals the number of leaves. Okay, so one last final bit of notes. Let's recap everything we've done so far. Wow, and I cannot spell. I'm full of mistakes today, guys. So sorry. Recap. We did r equals a, and that created just a circle at that particular value. Then we did theta equaling some angle in radians, some angle alpha in radians, and that was a line. Alright, then the other video you watched had r equals a cosine theta, or r equals a sine theta. And who remembers what graph that made? That also made a circle. And then today we talked about a plus b cosine theta, or r equals a plus b sine theta, and this was a limacon, and they were special because if it was a equals b, that created the cardioid. A less than b created which one? Well, if you need to, flip back in your notes, and a less than b was the inner loop, but a greater than b was the dimple. And then last but not least, we had r equals a sine n theta, or r equals a cosine n theta, and those were our roses. Okay, remembering if n was even, then you double the number of leaves, and if n was odd, that equals the number of leaves. So what I want you to do now is to go back to that paper that you have, Okay, well, wouldn't you know, I don't have a copy of the paper to tell you the exact numbers. But from memory, you should be able to do all of the problems except the bottom two that are r squared equals. We haven't talked about that type of graph yet. So, I want you to go back and do all the problems we haven't done. They should be graphing circles, limacons, and roses. And I will see you after the break, and we'll talk more about polar graphing. Have a great one, guys.